Colorants are commonly used in foods, cosmetic and drugs manufacturing to impart colors on product or set or physical characteristic. Colorants are used to create a brand or recognition for a product. Nowadays, colorants are a great option for industry to make product alluring and in tune with the environment.
The history of dyes, pigment, and paints. Pigment usage dates back to the Middle Stone Age with evidence of ochre-clay pigments dating back 100,000 to 70,000 years. During the late Neolithic and Bronze Age periods, pigment were utilized in paints for temple walls, tombs, ceramics, and homes, marking the transition from nomadic to sedentary lifestyle. The 19th century saw the advent of synthetic dyes like indigo by Bayer, revolutionizing color production. Later in the 1960s, organic dyes in DSSCs expanded application into renewable energy. Recent advancements in dyeing and pigment technology have transformed fabric production, allowing for a diverse array of colors and designs, meeting consumer demands for vibrant and appealing textile. By using technology, dyes have color because they absorb light in the visible spectrum between 400 to 700 nanometer, contain a chromophore, have a conjugated system, and exhibit electron resonance. This table illustrates the relationship between wavelength of light absorption and resulting color in organic dyes. Dyes offer intense color even at low concentration and dissolve easily in solvent for uniform application. They are compatible with various materials like fibers, paper, leather, and plastic, adhering strongly and maintaining color stability. Their fastness properties ensure durability against light washing and rubbing. Natural colorants can be classified based on their chemical structure, origin, and application method. Dyes can be manufactured in various ways, including extraction. Before starting the extraction process, determining the solubility of natural dyes is crucial due to the complexity of processing. There are few extraction techniques can be used, which are A. Solvent extraction. Use organic solvents for extraction. Simple, cost-effective, and suitable for various dyes. B. Aqueous extraction. Use water as a solvent, ideal for heat-sensitive compounds but may have longer extraction times. These are other ways to manufacture dyes. Reactors facilitate chemical reaction to create desired dyes molecules. Examples include microfluidic and continuous state tank react. Chemical reactions create dye molecules through processes like sulfonation, halogenation, and coupling. Separation techniques including distillation and precipitation isolate dyes from impurity. Additives improve dye performance and color stability. Examples include optical brighteners, dye leveling agents, and so on. Finishing operations ready resynthesized dye for commercial use, ensuring quality and stability. This includes drying, grinding for uniformity, and standardization for consistency. Quality control ensures dye consistency and reliability, meeting standards. Methods include spectroscopy, chromatography, and mass spectrometry for analysis. Environmental impact of dye manufacturing includes air pollution, VOC, NO, HCl, SO, water pollution, toxic influence, high wastewater volume with BOD or COD, and solid waste, filtration sludge, and toxic residue. During dye manufacturing, we focus on pollution prevention and control. This includes optimizing processes, substituting toxic dyes with safer alternatives, and using machinery with automatic controls. Air emissions are controlled through stack gas scrubbing, carbon adsorption, and combustion methods. Scrubbers remove pollutants, activated carbon captures contaminant, and combustion destroy toxic organisms. Liquid effluents are treated through neutralization, flocculation, settling, carbon adsorption, oxidation detoxification, and biological treatment, along with filtration techniques.
Proceed to pigments. Pigment can be defined as colored, black, white, or fluorescent particulate organic and inorganic solids that are usually insoluble in and mostly unaffected by the vehicle or substrate into which they are implemented. Their effects appearance through selective light absorption or dispersion. Pigments distribute in mediums or substrates such as inks, paint, plastic, or other polymeric materials. Pigment maintain a crystal or particle form throughout the coloration process. The physical characteristics of pigments are mostly colloidal in nature, with typical particles ranging from 0.03 to 0.15 micrometers in diameter and surface areas of 70 to 90 meters square per gram. The smaller the pigment particles, the greater the surface area, the more vulnerable the pigment is to the degradation of sunlight, chemicals, and other environmental conditions associated with surface exposure. The opacity or transparency of pigments impact their capacity to let light pass through, influencing the final appearance of colored material. Chemical stability is essential for pigments to withstand deterioration or chemical reaction caused by environmental elements such as light, heat, moisture, or chemicals. This can be quantified as fastness scale starting from 1 poor to 5 excellent in all circumstances, except light fastness, with 1 indicating complete failure and 8 indicating extraordinary performance. The term light fast refers to a pigment's capacity to survive direct and indirect light exposure, both natural and artificial, without changing its look. There are two types of pigments which are organic, carbon-based and inorganic pigments are frequently synthesized using petrochemicals or taken from natural sources such as plants, animals or minerals. Aromatic hydrocarbons such as benzene, toluene and xylene were commonly utilized as starting materials in the synthesis of carbon-based compounds, as were aliphatic hydrocarbons such as alkenes, alkanes and alkynes. In contrast, inorganic pigments are produced using basic ingredients derived from mineral deposits and metal complexes such as iron oxide. The initial stage is to source raw materials. Pigment produced from natural sources including minerals, plants and animals or chemically synthesized, depending on the intended color and use. On the basic components are received, the raw materials are prepared and mixed to create the required pigment mixture. This can include grinding, crushing and pulverizing raw materials to produce fine particles. Purification and refinement techniques are used to ensure that pigments are pure and high grade. These could include eliminating contaminants, filtering and centrifuging the pigment mixture. Next, pigments are wet and disseminated in a liquid or solid carrier. To acquire the correct color, strength and particle size, the pigment mixture is ground and melted. This helps break down the pigment particles to a fine and uniform size. Throughout the pigment manufacturing process, rigorous testing and quality control measures are implemented. Once the pigments are manufactured and tested, they are packaged into suitable containers such as jars, drums or bulk bags ready. There are two types of pigments, inorganic and organic pigments. Inorganic pigments are classified by four, which are white pigments such as titanium dioxide, colored pigment like ultramarine pigments, black pigments like carbon black pigments, and special pigments. While for organic pigments that include white pigments due to its optical action, which is based on non-selective light scattering. Colored pigments of organic compounds such as azo pigment, coupling reaction, and black pigments from charred animal bones. Both organic and inorganic have the special pigments which consist of effect pigments, transparent pigments, luminescent pigments, magnetic pigments, and anti-corrosive pigments.
Paint is a unique homogeneous mixture of three major ingredients, which are binder, pigment, VOC, and additive. A good paint should have a high hiding power, required color, resistant to atmospheric condition, washable, resistant to corrosion and shape changes. Base is the solid substance that forms the body of the paint. It is a very fine powder and vital to make the paint opaque, hardened, elastic, and prevent the formation of cracks. There is two types of pigment, which is prime pigment and extended pigment. Prime pigment is the colorant to paint. Extended pigment is the filler. Filler increase the bulk volume. Solvent is the dissolved ingredient in the paint and control the consistency of the finished product. Dryer accelerate process of drying of the paint, such as manganese. Additive is a substance added to paint to improve its performance and alter its properties. Manufacturing of decorative gloss paint. Drying oil, such as linseed oil and soybean oil, are oxygen carrier that is used to accelerate the drying time of the film through oxidation and polymerization. So this unsaturated oil polymerized by a reaction mechanism involving peroxide intermediate, and drying oils are used as a catalyst. However, too rapid drying are not desirable since it will cause surface wrinkling. For example, decorative cloth paint typically contain alkyd polymer that produced from polyol such as propene 1,2,3-triol glycerol with dibasic acid such as benzene 1,2-dicarboxylic phthalic and hydride along with drying oil. So all of the raw material are being heated together. The monoglyceride then react with anhydride to form alkyd polymer. The alkyd resin has a relative molecular mass of approximately 10,000 to 50,000 and are commonly carried in organic solvent. Solvent from petrochemical feedstock white spirit, which is a mixture of aliphatic and alicyclic hydrocarbon, are used as a solvent. Once the alkyd resin is applied, dependent oil drying groups react with the oxygen in the air to form a cross-linked hard thermoset coating with a high molecular mass. The paste mixture is rolled into a sand mill, a large cylinder that agitates tiny particles of sand or silica to grind the pigment particle, making it smaller and dispersing them through the mixture. The mixture is then filtered to remove the sand particle. Then, a circular blade linked to a rotating shaft agitate the pre-mixed paste at high speed. This process blends the pigment into the solvent. Grinding and milling process are vital to achieve the desired consistency and smoothness. This process is typically done in a horizontal or vertical roller mill. The paint will be crushed and milled until desired consistency is achieved. In the thinning process, the paste is transferred to a large kettle, agitated with proper amount of solvent for the desired paint. The last process of paint manufacturing is the quality control and tasting. This process involves evaluating the paint physical and chemical properties to ensure the desired specification and customer requirement are met. Lastly, the paint is packaged in containers and then shipped to retailer or directly to customer. Paints are classified as water-based and oil-based. Water-based paint is a mixture of pigment, binder, dryer, and mainly water, while oil-based are made with alkyd.
The first one is textile industry. Dyes are used to add brilliant and long-lasting color to a variety of fibers, including cotton, wool, silk, and synthetic fibers, such as polyester and nylon. To produce desired color effects, many dyeing procedures are used, including batch dyeing, continuous dye, and garment dyeing. Pigments are widely used in printing purposes, where pigment-based ink are applied to fabrics using processes such as screen printing and rotary printing to produce detailed design and patterns. Because of the physical properties of pigments can absorb wavelength of light, it can provide protection to human skin from UV radiation. Next, plastic industry. Dyes are commonly used in transparent or translucent plastics to add vibrant and translucent colors to products such as bottle, packaging, and displays. Pigments, on the other hand, are favored for opaque plastic because they provide good coverage and color consistency in applications like automobile components, household appliance. Additionally, pigments improve the UV resistance and weatherability of plastic items, assuring color stability and longevity. Printing industry. Dyes are frequently employed in dye-based inks for inkjet printing technologies because of the excellent color strength and transparency. These inks print sharply and vividly on a variety of substrates, including paper, textile, and plastic, favoring them to widely used in graphic arts, photography, and textile printing. Conversely, pigments offer superior opacity, light fastness, and durability, which makes them the material of choice for applications like offset, flexographic, and gravure printing that call for durable prints with brilliant colors. Construction industry. These pigmented coatings protect buildings from environmental elements like dampness, abrasion, and UV rays, in addition to improving their aesthetic appeal. Due to their stability, opacity, and color fastness, inorganic pigments like titanium dioxide and iron dioxide are favored for external application where long-term performance is crucial. Lastly, automotive industry. Pigments are a crucial part of vehicle coatings to achieve metallic and iridescent effects. Metallic pigments, which are made of aluminum flakes coated in different metal oxides, are commonly used in car finishes. In car-based coats, for example, organic pigments like phthalocyanine, blues, and greens are utilized to provide bright, long-lasting colors, while inorganic pigments like iron oxide provide superior opacity and weather durability.
So in sum, dyes, pigment, and paints are indispensable components in the industrial world. The economic value generated by dyes, pigment, and paint was high demand, especially in major sectors. Manufacturing of dyes, pigment, and paint has a strong presence in research development of new and innovative production, as well as their commitment to sustainability and eco-friendliness.